The next question of the numerical type. A cylindrical billet, 3-inch long, 1.5-inch dia, is extruded to a dia of 0.375 inch at a ram speed of 20 inch per minute using a 90-degree die. Empirical constants A and B are 0.8 and 1.5 respectively. Metal flow constants are 75,000 psi and 0.25. Using average flow stress, determine ram pressure, ram force and power in horsepower. And as a help, 1 horsepower is 550 foot-pound per second. So now, before you jump into the solution, think on it, right? As I said, first of all, pause my lecture here. You have the question in front of you. If you have done a very correct solution, then alhamdulillah. If your solution was not very nice, or even if it was right, repeat it so that you are well prepared for the final. So solve it, don't see the solution. So if you are listening to me after this, then you have already thoroughly solved it, right? So let us see the solution. It is extrusion, right? It is extrusion. It is extruded. It is extrusion, right? So this is one thing. The values are given in the PSI unit this time. PSI unit, foot-pound, PSI, and so on. So this is not metric system. This is important. It is not metric system. The dias and so on are given in inches. So this you note down, right? And you have to find the pressure and the force and the power. So, right? And one very critical thing is there. Empirical constants A and B. Empirical constants. Now you see, in extrusion, we told you that this is the ideal work, this is the redundant work, this is the friction work, and so on. And then we told you that because we don't have any direct mathematical equation at your level for redundant work and friction work and so on, therefore we can use an empirical formula, experimental formula, which is A plus B ln something. So that is the formula this time. Now 3/4 of the class is using the standard ideal extrusion and so on. So that is absolutely totally wrong, right? It is not a small mistake. It is not a calculation error. You see, when we are saying empirical constants A and B, empirical constants A and B, so look for the equation in extrusion where A and B are there in the extrusion. Otherwise you are going somewhere totally wrong, and I don't know then what are you doing, where you are going. That is why I always say, read the problem carefully, see what is there, and then plan everything, right? So after this introduction, then just go ahead. We always tell you that write the data first. So it is a cylindrical billet, length is 3 inch, initial dia is this, final dia is this, velocity of extrusion is this. The empirical formula constants A and B are this, right? The K and N, the metal flow constants, K is this, N is this. And we want to find the pressure, the force, and the power. And this is given to us, right? So let us see. I always say that start at the end and go back. So this is your formula. This is it. P is equal to Y A plus B ln R. That is it, as simple as this. I mean, why would you go to ideal and this and that? See, we know that empirical, if the redundant work and so on are not given. You see, in the previous one in wire drawing, they did an indirect method that we are not giving you the equation for redundant work, but redundant plus friction is equal to 40% of ideal. So this time they are saying just use the experimental equation. So, right, so don't go into an unknown area. Otherwise, I mean, to help you out, I sometimes give you 2-3 marks just for attempting it, but I should become really upset and give it a big cross and give you a big 0 if you see we are saying that empirical constants are given and you are using the ideal force, right? So please, when the questions are there, read them carefully, give it 1 extra minute, but read it carefully always. we were doing this problem, we have discussed it in detail, the data we have discussed, and that this is the equation, y is equal to a plus b ln r. So now things are very simple. You see, a and b are already given. What is r? R is a naught by af. And what is y? What is y, or the flow stress? This is k epsilon n, right? K epsilon n. So, right? So epsilon is ln r, and this is ln a naught by af, which is also ln d naught squared by df square, right? Pi by 4 can cancel away. So is d naught given? Is df given? Yes, d naught and df are given. Put the values here. You have found out epsilon, right? Is k and n given? Yes, k and n are given. So once the epsilon is there, put k and n. So sigma or y, right? This sigma is the same as y, flow stress. Once this is there, put y there. A and b are already known. Ln r you have already calculated, right? Ln r you have already calculated. So this is the pressure. This is the pressure. And remember, this will be in PSI, pounds per square inch. Either you write lb upon inch square, pound per square inch, or write PSI. And you can write kilo PSI, mega PSI, that is up to you, right? So don't use inch pound system and then write the answer as Pascal or megapascal. So then this again, naudzubillah, if it happens with 2 or 3 of you or 5 or 10 of you, whatever, then this means that the bulb is totally off. The light is not on at all. This is again not calculation error. If we are doing PSI units and you write the pressure in megapascal, then the upper chamber is totally closed. So this is not very nice. Then the pressure is there. Force we had to find out. So force is pressure into area. Force is pressure into area. And remember, this is extrusion. This is extrusion. They are extruding, so they are applying the force to the billet. The billet is forced through the die, and then it is coming out. The final area, the extruded area, is a small, but the force or the pressure that the machine has to use is on the initial billet area. So this area will be the initial area. When they say what will be the pressure in extrusion or what will be the force in extrusion, then it is the force applied on the full billet, not at the end of the process. Yes, if they ask in the question what is the force at the end of the extrusion process, then you use the area of the final product. But here just use the initial dia to find the area. So this is it, right? That you have found the pressure and just multiply it by pi by 4 a naught square, and you have the force, right? You have the force. Now for power, right? Power, you had to find these 3 things, right? Pressure, force, and power. So what is the equation for power? Power is force into velocity, right? Power is force into velocity. Why are we using this? Because velocity is given, right? Velocity is given. Velocity is given. There are 2 ways. Sometimes they give a direct pressure formula, power formula. Power is equal to light in rolling, FLN upon 60,000, this and that. But in extrusion and wire drawing and so on, they don't give a separate power formula. So the basic thing, we did this in the previous problem on wire drawing, we are doing this in this problem on extrusion. Power is force into velocity. So this is it. This is not a big issue. Force you have already calculated. Velocity is already given here. Now just see that after you multiply force and velocity, what are the units that you get? What are the units that you get? The conversion is 1 horsepower is 550 foot-pound per second. Foot-pound per second. So if you are getting, say, inch-pound per minute, but because of the units, because they were inch units and pound units, PSI units. So your answer for the power, if it is inch-pound per second, then change second to minute 1 time and whatever value you have. then change inch to foot, right? You have inch pound per minute, so change your minute to second, change your inch to foot. Once you have foot pound per second, then you know that you just use this 550 and you have the answer in horsepowers, right? So I have deliberately given this as a PSI. I told you during the courses, we have discussed it a few times, that there are some books in SI units only. The whole book is in metric units. But the problem is that if you are a real world engineer, then you will always deal with two big parts of the technology world. The US, Canada on one side and Europe on the other side. Europe will be all metric system. America, USA will be all inch pound system. So you cannot deal with these two and get some machinery from here, get some quotation from here, work with their engineers without knowing both the metric systems and the inch pound systems. Therefore, it is good for you to practice a few problems from time to time in the inch pound system. The metric system you of course know already, right? So this finishes all the numerical part and all the theoretical part and everything.